Okay, quiz tomorrow on some basics of rigid motions, translations, reflections, rotations. And here's the first question from review for quiz number 2. All right, the first step in transforming triangle ABC is working backwards. You're going to reflect it over the line x equals -6. X equals -6 is the one that I outlined in purple. So your first step is to reflect the original triangle right here over x equals -6, and you end up over here. The second step is to take that new shape, the image, and reflect it over a different line, x equals 1, which is right here. Not to be confused with the axis. It gets a little confusing when you see the axes and these extra lines, but we're going to ignore the axes and reflect over the orange line, x equals 1. So if I go over 4, I go over 4 more. A double prime. If I go over 4, I go over 4 more. B double prime. From C prime, I go over 7, so I go over 7 more. C double prime. And this is my final image after both reflections, which were over parallel lines. And this isn't part of the question, but you could have accomplished the original to the double primes by a translation. And that translation would have brought you straight over 14 boxes. So instead of doing 2 reflections that we did there, we went over 14 boxes. And if you notice, there were 7 boxes between the 2 parallel lines. When you double the distance between the parallel lines, you get the translation distance, which was 14. So if you wanted to, you could say the same thing could have been accomplished by a translation of 14,0 of triangle ABC. I'm going to reuse this graph paper as much as I can. You might want to write lightly and then erase each time, because this is basically a scrap piece of graph paper to keep reusing. In number 2, you're taking the point -5, 6, right there, and you're translating it by -6, 3. So that's going to actually go off the page by 1 and end up there. And even though it's off the grid, you still know it's backwards 11 because it's only 1 box off the page. So we're back 11 and we're up 9. You can just do the math right here. -5 minus 6 and 6 plus 3. Puts you at -11, 9. Number 3, you're taking the point 5, 4, right there, and you're rotating it 90 degrees. So here's where you use your patty paper. I say anytime you're rotating, go to the patty paper if you want, unless you like the rules better. So there's my patty paper overlaid. And I'm going to rotate this 90 degrees clockwise, or counterclockwise, I'm sorry, positive 90 is counterclockwise, and that puts me at -4, 5. Next one says take the point -3, 1 and rotate it 180 degrees around the origin. So I'm going to rotate that 180 degrees with your patty paper, and you're going to end up at 3, -1. You can almost see the rule there. You just change both signs when you're rotating 180, if you like the rules. The next one is the line y equals x. And if you remember, the line y equals x is a perfectly diagonal line with a y-intercept of 0 and a slope of 1. And there's 2 ways to do this. You can count boxes diagonally, or remember the easy rule. 10, -2 is right there. You could, if you wanted to, count diagonals. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Because remember, it has to meet perpendicularly. And that puts you at -2, 10. Well, if you look at -2, 10, what happened? You just swapped the coordinates. Instead of xy, it's now yx. And that's true with the rule y equals x. The next one says reflect the point -4, 3 over the line x equals 3. The line x equals 3 cuts through the x-axis at 3. So we went over 7 and then over 7 more. And that puts us at 10, 3. There is no rule when you're reflecting over lines that aren't the axes or y equals x or a special line. When it's a random line, counting boxes is the best way to go. Point 37 is right here. I'm going to rotate that -90 with my patty paper. So I lay my patty paper on top, I put the plus sign on the origin, making little axes. -90 is to the right, or clockwise. And that ends up at, went a little too far there. Wouldn't happen with your patty paper. That puts the point at 7, -3. And the last one on the first page, you're taking the point -9, -3, and you're going to move it to the right 2 and down 4, which is right there. And that happens to be -7, -7. Could have done that just with the math too. -9 plus 2 is -7. -3 minus 4 is -7. On number 9, the line of reflection is y equals -3, which is, do a better job than that, right there. And you're taking the point 4, 2 and reflecting it over that line. So you're going down 5, down 5. And that puts you at 4, -8. Number 10, the y-axis, we know where that is, and we are saying that we landed at 114. Now granted, that's off the grid, but this is just to guide you. 114 would be right up there, over 1, up 14. And if you were going to visualize this, where must it have come from? Just the other side of that line, which is right here. So it just would be -114. And you can know your rules there. Even though it's off the grid, that's not an excuse, because you can tell that you're just on one side of the y-axis by one box and one side on the other, and the 14 wouldn't change. Okay. After a translation, you landed at 6, 8, which is right here. That was after you moved -1, 4. Where did you start after moving -1, 4? You can just add 1 and subtract 4 to find out where you actually started. So if you add 1, you would be at 7. If you subtracted 4, you'd be at 4. Let's see if that makes sense. 7, 4. If I started at green and wanted to go to pink, am I going -1, 4? Yep, it worked. -1 up 4. So when you're looking at a translation and it gives you the final answer and asks you for the original, just do the opposite of the signs in the translation. I'm not going to write the answer to 12 because I want you to hear me and I don't want you to just copy it down. I want you to understand it. It says that D prime, E prime, F prime, G prime is the image of DEFG after it was rotated 180 degrees. Why is it congruent? The reason is a rotation is a rigid motion, and rigid motions preserve angle and distance. And that makes it congruent. So because it told us it was rotated, well, a rotation we know is a rigid motion because the definition is it preserves size and angle. That is why it is congruent. Number 13. We're going to take point A and reflect it over line N. There's point A, there's line N. It has to meet at 90 degrees, so you land at B. The next question, you're taking point C and you're reflecting it over line M. C is on line M, it doesn't move. It's an invariant point. Next question, you're taking point G and reflecting over the segment BD. You have to go perpendicular across that line of reflection, which puts you at F. And the last one, you're taking point D and you're rotating it a negative 180 about the middle origin, or point O there. Well, 180 is going to flip it completely around to the other side, whether you go positive or negative, and you're going to end up opposite that at point B. The quiz will be quite similar to this tomorrow.